Alright guys, let's open it up. Yep, Victron. So this came from a company that I've never used before, but I recently kind of found them on the internet, and they have really good prices on this gear. A company called Inverter Supply. Just a little plug for that company. They did not sponsor us anything. I paid for this with my own money. Let's crack it open. Looks like it had already been opened. So I'm over here talking this company up, and maybe they sent me something that's been used. Hopefully not. I'm gonna have to go through this. It's a big, thick guy, mainly because it's multi-language. But let's pull this beast out. Interesting. So it came with a MC4 tool. Okay. I needed one of those. I guess it's a little flyer here that shows other products. I'm guessing it came with this because this is the MC4 version. Oh, this thing is heavy. Wow. Solid, very solid. I think this is metal. We've got the V-Direct connector, which I'm not going to really probably use because this model has the Bluetooth built in. It can also use the screen, which I might get, but I don't know if I need it because I can just use my phone. And it has 3 MC4 inputs. So each one of these can carry 30 amps. And they are just paralleled internally here. So you would still need to, if you had multiple arrays connected to this, you still need to fuse or use a breaker, for each one. All right. Battery terminals, very, very large. That is beefy. I feel like you could get a number 2 in there, maybe bigger. It has their Victron CAN bus. This is one thing that I really like. It has a relay, a programmable relay output here. So you can program this relay to do things like trip whenever the battery is low, so you could turn loads off and things like that. It actually has other functions that you can set up in the software. And this remote control, which I won't really be using. This is just for other equipment to turn off the charge controller. Like if you've got, I don't know, a battery with a relay on it that doesn't necessarily speak the language of Victron. Oh man, the construction is just quite high quality. So this one, which may be slightly disappointing to some of you guys, this one, as big as it is, it actually only does 12 and 24 volt. I got it at a substantial discount because of that. The same model that goes 12, 24, 36, 48 is substantially more expensive, which is fine. I actually really only wanted to use this for 24 volt. I've got other ones for 48 volt if I need it. PV input is 150 volts max. You can do 70 amps max on the PV input. The battery output is 12 or 24 volt, 85 amps. Operating temperature is -30 to +60 Celsius. External fuse interrupting rating 100 amp minimum, up to 120 amp. So yeah, you need a 100 amp breaker at least, or 120 amp breaker or fuse. That's an overview of it. All right, so I've got this big, blue, beautiful beast of a charge controller wired in for some testing. And yeah, I've got to go ahead and admit I've already kind of plugged it up, got into the app, and So far, I've got nothing bad to say. I'm actually quite impressed. I downloaded the app from the App Store. It installed, did not give me any problems, very quick. Found the charge controller. It immediately said, hey, your firmware is old on the charge controller. I think it was like version 1 point something. And it says we've got 3, which is quite a bit newer, clearly. And it updated automatically from the app. So it updated my charge controller. That's really neat, guys. That's something that I'm not used to for charge controllers. That's incredible that it's just updates like that for me. So that makes me feel like these guys are really on top of things. Let's connect, fetching data. So I don't have both sides of the PV connected yet. Oh, actually, you know what? Let's pull it up on my tablet too. No, not weather. I know I downloaded it. Where is it at? Oh, there it is. So can we have multiple things connected? Obviously. Let's see. It's telling me it wants me to change the pin, but I won't do that right now. So maybe it does not necessarily like multiple devices connected. Let's try it again. Yeah, it looks like it's grayed out. So I guess one smartphone device at a time. No problem. I'm not concerned with that. So, hold on a sec. Sir, no. Do not eat that. No. Look at this guy. My pup is eating the carpet. Say hello. This is Power. Oh, he's freaked out a little bit about the camera. You baby boy. He's only like a little over 4 months. Belgian Malinois. All right, guys. So let's plug in some solar. Okay. All right. So it's showing 76 volts on the solar. Oh, okay. Now there we go. Now we're getting some power. Okay. Almost 600 watts. No. Go inside. All right, so almost 600 watts there. We're only getting, 9.2 amps, so just a fraction of what this thing can handle. Oh man. I definitely have a lot more solar I can plug in, but not at this very moment. That's just from my solar tracking array. And since it's fall, the sun is a little bit out. It's a little further out to the south. So we're not directly on these panels. These panels are 435 watts a piece. So right now, just a little under 600 watts. Because we don't have optimum angle. So I guess what I really would like to do at this point is let me turn this inverter on and see if we can put more load on and see if we pull any more, but I think that's probably what we're going to be maxed out at because of the solar panels. Well, climbing up a little bit. And I can tell you right now, this thing is cold as ice, ice cold. Ice cold. So really what I kind of want to do at this point is try to gauge the efficiency. Let me go ahead and turn this inverter off. So it's saying 580 watts, showing 41.9 amps going to the battery. That's showing 571 watts going to the battery. So I'm wondering where it's reading this. Is this what it's thinking it's going to the battery, or is this what it's thinking is coming into the solar? So let's do a measurement on the solar. It says 9.4. 9.45. Let's just say 9.5. 9.5 times, I don't know, 62.58. So that's showing 594 going in. So I guess that right there is what it's calculating is going to the battery. So if we got 594 going in, 580 going out, what is that efficiency? That sounds pretty efficient. Well, I think that's the most efficient charge controller that I've got thus far. It is showing, can you see, 97.559 efficient. Wow. 97.559. Set. While we were doing this test, I got a package. I think this is, let me look. This is a package from a viewer. I'm going to keep his personal information out of sight. I know most of you guys aren't going to harass anybody, but some of you guys will. I've had some strange messages from some people. Anyways, this is from a viewer that sent in this into the channel, and let's open it up. Should we use a chisel? All right, so this is from a viewer by the name of Brett. I hope he doesn't mind that I mention his name. We were chatting on the DIY solar forums about some charge controllers, and he had noticed that I've got a crappy meter, and he said that, well, he's an engineer and he's got a bunch, and several just not doing anything, and he doesn't need more than one, so he donated this to the channel. Let's take a look. Wow. Look at that. A Fluke 189 multimeter. My goodness. Brett, you are too much, guy. That is amazing. Wow. I've always wanted a Fluke. The probes have not even been used. They're still wrapped up. But if your job depends on it, this is the equipment you get. And I'm a big fan of that kind of thing. Wow. Let's see. Do we have batteries? Yeah. Look at that. AC voltage, AC millivolts, DC voltage, DC millivolts. There's our ohms, diode test, temperature. We got AC amps, AC microamps. We got DC amperage, DC microamps. Clear min. I'm not sure what that is. Look at this logging. All kinds of functionality. So I'm going to have to find the manual for this online and figure out how to use it. But I think we can probably do a real quick test here. It just feels like quality, guys. That's, you know, you can tell when they've put some effort into something. It just feels great. Alright, so we're at DC voltage. Let's just do a little probe. Sorry for hijacking this video with this, but this just came in. The doorbell just rang. And I'm actually quite excited, and I'm very grateful to Brad. Thank you so much again. Look at that. 13.8. Wonderful. Again, one last time, thank you so much, Brad, for donating this to the channel. The channel's quite small still, but I want to just say thanks to all of the viewers and everybody that watches these videos. I honestly did not think that I would get views. I just started posting a few videos and noticing that people were interested in them, especially the battery videos. You guys love batteries. DIY batteries. That was actually the batteries from Battery Hookup. Was what you guys probably the first videos that really took off a little bit. I mean, nothing viral or anything like that, but you know, in the thousands of views. And I'm like, well, people are interested in this. So anyways, that's what really made me want to continue to do it. Plus, I'm always playing around and doing experiments, and I've always wanted to share them, and that's what this channel is mostly about. But I've had some manufacturers help and do some sponsors. You know, some little things. I would definitely say that I'm not making a living doing this by any means. I have a full-time job. I'm a software engineer, if anybody was interested in knowing that. But no, this whole endeavor, this YouTube channel, is not in any kind of cash flow positive or anything like that, any stretch of the mile. But I'm going to keep doing it, and eventually it would be fantastic if it all pays for itself, and maybe makes money, and then we could hire people. That would be fantastic. I was honestly know that I was thinking about this before we hit the 1,000 subscribers mark, which is when we're able to monetize videos on YouTube. And I was kind of thinking, wow, it'd be really great to get to that mark so that we could, you know, get a little bit of money from the videos and put it back into the channel, because that's really where it's going. And we reached that. So we're at 1,225 as of today. Pretty awesome. So thank you guys for watching. And again, thank you, Brett, for donating this this piece of equipment, and it's going to make a world of difference to the channel. So let me get that out of the way. I'm going to put this beautiful meter up where it's safe for now. Of course, as I use it in the future, You know how we are whenever we get a new toy. We're very cautious with it and cleaning it and making sure it doesn't get scratched. Then after a while, you know, you toss things around. I'm not going to toss it around. I'm not going to disrespect this piece of equipment like that. But for now, I'm going to put it up. And we will be using it in future videos for sure. Okay, so we are, we're very low on wattage, so that probably means that the battery is like topped off, and I need to turn this back on to suck some power out of the battery and get that thing going again. There we go. I'm sorry about the noise. This inverter right here is loud and obnoxious. Funny thing is that I have modified this. So I put some Zener diodes into this thing in the fan leads to lower the voltage down to like 7 volts to these fans, so they're not running the full 12 volts. I think it's like 7 or 9 right now, and it's still a little bit loud. But before I did that, this thing was like a rocket ship. So loud. Anyways, all right, let's see. All right, let's look at the settings here. So battery settings. I already set this up. So right now we're doing 12 volt. You can do 12 or 24. It has these battery presets, and I've got it just set to their smart lithium iron phosphate battery preset. I think that's a battery that Victron sells, but that would be the clearly the closest to lithium iron phosphate battery, because that's what it is. I'm sure they have some kind of communication, but we're not clearly going to be using that. Shows the absorption voltage at 14.2, float voltage is 13.5. Equalization is disabled. Clearly you would have that disabled for a lithium battery. That's for your lead acid style batteries. No equalization. No temperature compensation. That's something that is not used for lithium. And a low temperature cutoff. Now that's a good setting right there, guys. Because especially if you have a battery that does not have this built in, the charge controller has it built in. So it's set for 5 degrees Celsius, so not quite freezing. So I could change this if I wanted to. I'll do it later if I need to. So that's a nice feature. If it goes below that temperature, the charge controller will stop charging your battery and save your lithium batteries from being destroyed. I think this controls maybe the relay or something, or I'm not sure. Actually, no, it doesn't control it because there's a relay right here. So you can set up the function of the relay. So there's relay always off, the panel voltage is high, high temperature, equalization active, error state, defrost, battery voltage is high, float or storage state, day detection, load output. Let's see. Not sure. I did hear the relay click off. So if I use this, it'll be the, no, not equalization. It'll be the battery voltage low. So I'll use this to turn off things like inverters or whatever the loads are if the battery voltage is low. I might end up using it to do some solar mining, and so I'll be able to turn those off if the battery voltage is low to keep the battery from fully draining down. The other thing that this thing has that a lot of charge controllers don't have is if your battery does in fact drain all the way down and shut off, this thing is okay because it will power itself off the solar. So when the solar comes up in the morning, it will power itself, and then it will send the correct voltage down to the battery to wake the BMS back up. Bam. So that's an sweet feature. It has like a street light function, not going to use that. Transmit port function, I think that's part of the relay, I think. Things that I won't be using. Display temperature units in Celsius or Fahrenheit. The Victron Smart Networking. So if I create like a network, like kind of, I guess, a virtual network, then all my Victron devices can communicate to one another. So that's fantastic. I've only got one Victron device, so I don't know what that's like. I desperately want to get a Victron Multiplus to go along with this, but I don't know. We'll see. So right now, what I want to do is I want to check the temperature. I can already tell you that I can feel no temperature change. So I got to turn this thing back on to get it to draw some power. But let's see. 88 ambient really jumps up to 91. But I don't think that's correct, because I literally feel no difference between this surface and this surface. So these tend to have a little bit of a calibration issue depending on what kind of surface you're shooting at. So let's see, 86 on the wood, 86 here, 91 there. So just a slight increase, which is interesting because I just don't feel any different. Let's see here. Like there. So just a slight increase in thermals. I totally do not feel anything under that is warm. It says 92 under there. And we're doing the 560 some odd watts. Yeah, guys, so yeah, I'm curious. I wish I knew what kind of buck converter topology this thing used. I feel like it's more efficient than most of them. Like maybe they've used a synchronous buck conversion, which if you ever look at a schematic for a buck converter on the internet, which is basically what these are, with an algorithm that looks for the maximum power point of the solar panel, and it changes the load on the input here to match that power point, so it causes the panels to produce the most. But it's mainly a big, DC-DC converter, really, that is smart. If you look at the schematics of a buck converter on the internet, you'll see that there's a diode in the buck converter, and so when that diode becomes active in between the cycles, if you've ever played around with diodes, they have a forward voltage drop. That forward voltage drop burns energy, and so it heats up and energy gets lost in that diode. When you have a synchronous buck converter, you can look up that schematic as well. It replaces that diode with a MOSFET, and the MOSFET is then controlled by the controller, so it comes on when it needs to. So when the controller is switching the main switching MOSFET to do the buck conversion, it knows to also switch the I think they call it an ideal diode MOSFET at the correct timing. So it dramatically reduces that voltage drop that the diode experiences and wasting heat. So I think that's one of the reasons. I could be wrong. I don't know how these work, but I don't feel any, like I said, don't feel any warmth coming from here, so it's not burning any power, or very little. And I feel like this is probably using a synchronous buck converter. So guys, I think that's going to be the end of the video. So far I'm quite happy with this controller. It is clearly a step above and beyond most of the controllers that I've played with. The quality is just substantial. You can tell the craftsmanship is there. The software works amazingly. It updated itself. No problems whatsoever. It seems to be incredibly efficient, and I look forward to actually putting some good use through it and getting some long-term experience with it. And having the Bluetooth built in, I'm actually really interested in connecting to other, having it to communicate with other Victron devices. And I think that's kind of where these guys get you, is like I feel like once you experience this, then you're kind of hooked, and you're going to want to use their Victron ecosystem of devices. And again, they're expensive, but really they're not that expensive compared to some other companies out there, like the Schneider and the Midnight Classic and the Outback controllers. And there's a bunch of ones that are available that are more expensive than this. And this seems to be the cream of the crop, really. Okay, anyways, guys, this really is the end of the video. Thanks again to Brett for the fluke. And that's it. I'll see you guys on the next video.